In lesson 9.4, we get a little bit of a reprieve from learning any new transformations. So we won't see any new transformations in this lesson, but we're going to talk about the transformations that we've already learned and how they can lead to symmetry. And I'm sure you've heard this term before in probably many different regards, but in geometry we want to be very specific about symmetry. Any figure is going to have symmetry if there's an isometry that maps the figure onto itself. So if I can slide the figure and slide it on top of itself, or rotate it and it then rotates and looks like itself. So any sort of isometry that you end up getting the figure that you started with, that's going to be something that has symmetry. And we're going to talk about several different types of symmetry. And I think it'll make a little more sense once we start visualizing this. So the first specific type of symmetry that we're going to look at is reflectional. So it's going to have reflectional symmetry if there's a reflection that maps the figure onto itself. So any symmetry would be any sort of isometry that maps it onto itself. Reflectional symmetry is when it's a reflection that maps the figure onto itself. And then line symmetry is the same. So if you hear someone say line symmetry, that's just another fancy way of saying reflectional symmetry. Okay, so let's take a look at an example. Here we have a heart shape, and we can see a dashed line going down through the center. Notice if you were to take this side and reflect it across this line over onto this side, you would get what we see here. And if you were to take this and reflect it back over, you would get what we see here. So the dashed line is our line of symmetry, and if we were to reflect that figure across that line of symmetry, we would get the exact same figure that we started with. So this heart shape figure has reflectional or line symmetry. And actually we saw this, there were some practice problems before where we were reflecting across the y-axis, and there was a trapezoid. And everyone was kind of confused, like, well, won't I just get the exact same thing? You absolutely would, and that was an example of a line of symmetry for an object that has reflectional or line symmetry. So, a couple more. The next one, rotational symmetry. Hopefully we can figure out from the name here that this is going to be a type of symmetry where it's the rotation is mapping itself onto its image. And notice here it says if it is its own image for some rotation of 180 degrees or less. Obviously any figure that we take, if we rotate it 360 degrees, we would get right back to where we started. So it has to be 180 degrees or less in order for it to be rotational symmetry. And then this term point symmetry, something has point symmetry if it has 180 degree rotational symmetry. So exactly 180 degrees. So rotational symmetry for anything 180 or less, and then point symmetry is a specific type of rotational symmetry where the rotational symmetry is exactly 180 degrees. So if we look at an example here, it says the figure is its own image after 1/2 turn. So it has rotational symmetry with a 180 degree angle of rotation, which we said is also called point symmetry. And we can see this, if we quickly just trace. It's going to be a little messy here, but you'll get the general outline. Right, so if we trace this figure, and then we rotate it exactly 180 degrees, so let me grab the image, and we're going to just rotate it around. Notice we get the same thing, right? So that was only 180 degrees. Obviously any image, if we do 360 degrees, we'll be right back to where we started. But point symmetry, a special type of rotational symmetry, is when it's exactly 180 degrees, which we can see here. Okay, onto the examples. Here they want us to identify the line of symmetry, so they want us to find the line of symmetry for an isosceles trapezoid. And so if we move this, we can see it really only has just the one, right? It just has one line of symmetry down the center. If we try to draw a diagonal, it's not going to be a line of symmetry. If we draw it horizontally and then reflected it, notice the wider end would be on the top, the narrower end would be on the bottom, so we would not have symmetry in that case. But the way the line is drawn here, we do in fact have a line of symmetry. Moving on to another one. Here we're looking for rotational symmetry for V and H. Well, if we look at the two letters, again, we can kind of trace these and just see what we come up with. So there's a V, kind of an ugly one, but notice if we bring our V down here, if we rotate it 180 degrees, we get an upside down V, right, which is not the same as the V that we see here. To get the same, we would have to go 360 degrees, so that one we can disregard. You have to rotate it 360 degrees. But if we take H, and we can trace H as well, and we can bring H down here, and if we rotate H, notice we only have to go 180 degrees, and our H looks the same. So in this case it does have rotational symmetry, and specifically we would say point symmetry, because we can rotate it exactly 180 degrees to get the symmetry. Alright, another example, and then the quick check, one of the quick checks will pop up. Here it says a nut holds a bolt in place. Some nuts have square faces, like the top view shown below. Tell whether the nut has rotational symmetry and or reflectional. And they want us to draw them. So I'm actually just going to kind of reveal this here. If we think about the square, we could draw a line here and it would have reflectional. Right? We could draw a line down the middle and it would have reflectional, horizontal, the other diagonal. So all three of these lines, four of these lines, 1, 2, 3, 4. All four of these lines represent the reflectional symmetry. And then if we think about this being a square, right, if we trace our square, and it's a circle in the middle, we know a circle, any amount that we rotate it, it's just going to stay a circle. But with our square here, we can see we can rotate this square 90 degrees and it's back to being a square, and 180 degrees and it's back to being a square. So this has 90 degree rotational symmetry, and we can see here there are 4 lines of symmetry as we trace through there. Some of this just takes a little bit of getting used to, a little bit of practice to recognize these lines of symmetry and where they pop up. So the first quick check has you draw a rectangle, and that's a really good one for trying out your hand in terms of finding the lines of symmetry. So give that one a try. And then part 2 gives you kind of a funky shape and has you identify what you think. Same thing with the umbrella. So go ahead, give those quick checks a whirl, and we will look over those in class.